Good day, learners. Welcome to Mathematics lesson. My name is Nonkululeko Mbuyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Okay, grade 11s. In today's lesson, we'll be looking at functions and graphs. At the end of this lesson, learners should be able to sketch the parabolic functions. Number 2, you should be able to sketch the parabola, a graph using the characteristics, the x-intercept. Remember, when you are finding the x-intercept, you need to say let y to be equals to 0, right? You need to know how to find the y-intercept, and for you to find the y-intercept, you need to say let x to be equals to 0. And you should be able to find the turning point. Remember, when we are talking about a parabolic function, it can either have a shape that goes like this, or it can have a shape that goes like that. So you need to know how to find that turning point, and you need to know how to find this turning point, okay? Again, we will be looking at the summary of parameters A, Q, and the P, okay? Okay, so we've got two equations. Remember, in grade 10, we're looking at the equation or the general equation of y. It is equals to ax squared plus the q, right? Whereby the q, we were talking about the shifting of the graph vertically. If you still remember, if you have y, it's equals to maybe x squared plus 1, then it means your graph has shifted 1 unit upwards. That is grade 10. Okay, so this year we will be introducing y is equals to ax squared plus bx plus c, and also a into x plus p plus the q, whereby now we are looking at the shift of the graph horizontally, whereby we are looking at that parameter p. Okay, so if your graph, it has got a which is greater than 0, remember a, it determines the shape of the graph. So if your a, it is greater than 0, or if your a is positive, your graph, it is going to have that, it's going to concave up, or it's going to have that smiley shape, right? Okay, so in your parabolic function, you have the x-intercept, which are those points that are on top of the x-axis. And also, you have the minimum point if your a, it is greater than 0, right? Because your graph is going to concave up and forming that minimum value there. Ne? And then you're going to have the line of symmetry. Remember, the line of symmetry, it's that line that cuts the graph into two equal halves, of which is this one. So it means you are going to say if the value of x here, for instance, it is positive 2, then it means the equation of the line of symmetry is going to be x, it is equals to 2. Ne? That line, that value of x of the turning point, it is going to cut the graph into two equal halves. And then again, the y-intercept, which is the point that is on top of the y-axis, it's going to be somewhere there. Ne? And what if your a, it is now less than 0? So if your a is less than 0, your graph is going to concave down like that. Ne? This one was concaving up. This one is going to concave down, or we say it is going to frown, right? This one is going to smile. This is just for you to remember, ne? And then, okay, so you'll have the maximum point there, or the maximum value, and then you are going to have your y-intercept. Remember that point that is on top of the y-axis, then we say that's your y-intercept. And then you are going to have your x-intercept again, which we are talking about these points that are on top of that line, the x-axis. So that point and these points, these are your x-intercept. And to find your x-intercept, remember, you need to let y to be equals to 0, because along the x-axis, your y is going to be equals to 0. And then you have the line of symmetry, which is going to be that value of x that cuts the graph into two equal halves. Okay? Okay, and then looking at that formula of y, it is equals to a into x plus p squared plus the q. For you to find the turning point, you need to say the p it's the value of x of the turning point. So the turning point they will be given by that p is 2, the q like that. So if your formula, or rather your graph, it is given as y is equals to a into x plus p all squared plus q, then you need to know that your p, it represents the value of x of the turning point, and your q, it represents the value of y of the turning point. And then if you are given the graph in terms of this, you can either find the two x-intercept, then you add them and divide by 2 so that you find this middle value, that value of x which is in the middle. It's like finding your midpoint, then you'll find the value of x. Or you can complete, if you complete a square, in y it's equals to ax squared plus bx plus c, you'll find that the value of x here, it is going to be negative b all over 2a. Then you substitute your value of b, and you also substitute your value of a, and then you'll find your value of x. After finding the value of x, you take that value of x, you substitute in that original equation to find the corresponding value of y. Okay. Let's look at how to sketch the parabolic function when you are given y, it is equals to ax squared plus bx plus c. So step number 1, you need to determine the y-intercept, and as I have said, for you to determine the y-intercept, you need to say let x to be equals to 0. And then step number 2, you need to determine the x-intercept by letting y to be equals to 0. And then step number 3, you need to determine the turning point by saying x is equals to negative b all over 2a, or you can add the 2x-intercept and you divide them by 2, and the answer that you get, you substitute in the original equation. And then step number 4, you substitute the x value of the turning point in the original equation of the parabola that I have said. And then step number 5, you can just plot the points. Okay, we are going to be doing it together because you have been doing the y-intercept and the x-intercept ever since grade 9. Okay, so we'll be doing it together when we are getting to the examples. Let's quickly look at the domains and the range. So remember, in grade 10 we said the domains, those are the x values where the graph is defined. So it's all the values of x that are covered by the graph. So when we are talking about a parabolic function, the values of x, your graph here, it's going to cover all the positive values of x. So if I'm looking from here and I'm concentrating only on the values of x, so it means these values of x that are negative, they are going to be covered by this graph, right? We don't know where it's going to end because it's a continuous function. So it means this side, all the negative infinity is going to be covered. And then from 0 again going this side, the values of x, they are covered, they are covered, they are covered, and also they are covered, they are covered, they are covered up until positive infinity. So it means when you are writing your domains, which are the values of x that are covered by the graph, you are going to say x is an element of negative infinity is to positive infinity, or you can just say x is an element of real numbers. And then when we are talking about the range, we are talking about the y values where the graph is defined, right? Whereby we are now looking at all the values of y that are covered by the graph. So if you have a smiley shape like this, it means when I'm concentrating on the values of y, it means I'm going to take from this value of y of the turning point, right? Because this is where the graph is going to start. It's going to start from this value of the turning point, which is the value of q, going all the way up. Then I'll say y, it is greater than or equals to q, because it starts exactly at that value of y of the turning point. I don't know if I'm making sense. Okay. And what if I have a graph that has got a shape that goes like this, which is concaving down? So now again, the values of x that are covered by the graph, your graph is going to cover all the, it's going to cover all the negative values of x. So it's going to cover this side, cover this side, cover this side. So all the negative values of x, they're going to be covered this side. And then this side, the positive values, they are going to be covered as well. I don't know if you can see. So it means even positive infinity is covered. So you can just say x is an element of real numbers, or you can say x is an element of negative infinity is to positive infinity. Those are your domains in a parabolic function. And then when it comes to the range, we are talking about the values of y, meaning that we are now going to concentrate on this line, the vertical line. So all the values that are covered by the graph from here going down, right? But always you start from the negative side. So it means y, it is going to be from this side going down, it's going to be less than or equals to this value of q that is given there. So if it's concaving up, then your y will be greater than or equals to this value of y at the turning point. And if it's concaving down, then it's going to be y is less than or equals to this value of y of the turning point. Okay? Let's look at example number 1. They're saying we need to sketch the graph of g of x. It is equals to x squared minus 6x plus 5. Okay, so 1.1, I'll give you exactly a minute for you to do that one. I'll give you a minute to determine the y-intercept. Determine your y-intercept and post in the chat so that I can see if you still remember how to find the y-intercept. I'm giving you exactly 1 minute. That shouldn't take you time. Okay, your 1 minute is up. So for you to find the y-intercept, we say, for you to find the y-intercept, we say let x to be equal to 0, right? So it means in this equation, in our g of x, where I see x, I am going to substitute a 0, or I'm going to replace it with 0. So it means I'll have g, I see x, I open a bracket, I substitute 0. It's equals to, again, I see x, I substitute 0, I square minus 6, I substitute x, 0, and plus 5. So your g at 0, it is equals to 5. Meaning that your y-intercept, it is going to be given as your x is 0, your y is going to be given as the 5. So you can either do this whole method, or you can just say, but that value of c, you know it's going to be your y-intercept in your graph. So it means your point will be given as 0 is to positive 5. And that is going to be 2 marks. Okay, so you'll get a mark for the correct substitution of 0 there, and for getting that g at 0 is equals to 5. Okay, quickly, let's move to 1.2. It says we must find the x-intercept. Again, I am going to give you just a minute, 1 minute. Find the x-intercept for me. Okay, your 1 minute is up. Okay, so we had said, how do you find the x-intercept? You are going to say the x-intercept. Then you need to let y to be equals to 0, right? Okay, so where I see y, remember your g of x is the same as y, ne? So it means you'll say it is 0, it is equals to x squared minus 6x plus the 5. If you can't find the factors, please just use a quadratic formula. Ne? You just use a quadratic formula if you can't find the factors. Remember your quadratic formula when we're still doing the algebra. Okay, but I am going to factorize. I'll open 2 sets of brackets. Then you put an x, you put an x. The factors of 5, that gives you a 6. It is going to be 5 and positive 1, right? And since it is positive there, it's going to be minus 5 and minus 1. So that when you say negative 5 times negative 1, you do get positive 5, right? And if you say minus 5 plus minus 1, you do get minus 6. And it's still equals to 0. Then you'll have x, it is equals to, if I transpose the negative 5, Okay, let me just do it step by step. It's x minus 5, it's equals to 0, or x minus 1, it's equals to 0. So it means x, it is equals to positive 1, because if I take the negative 1 to the other side, it is going to change the sign to be positive 1. And then again, it's going to be x, it is equals to, if I take the negative 5 to the other side, I'll get positive 5. So it means my coordinate of the x-intercept, I will have, when x is 5, we said y is 0. And again, when x is 1, y is 0 as well. Okay? So those are our coordinates of the x-intercept. So here you are going to get a mark for equating to 0. For letting y to be equal to 0, you get a mark. For factorizing, you get a mark. And you'll also get a mark for your x-intercept. And that's going to be your full 3 marks. Okay, let's quickly determine the turning point. I think I should just explain this one as well, ne? Because you haven't done the turning point when you are given ax squared plus bx plus c. So for you to find the turning point here, you need to say, okay, x, it is equals to negative b all over 2a, right? Then x, it is equals to negative, the b, it's going to be that coefficient of x, which is negative 6, all over 2, and your a, it is going to be that coefficient of x squared, which is 1, and then your x will be equals to negative times negative is going to give you a positive 6, all over 2 times 1, you'll get a 2, then your x, it is equals to 3. So now I do have the value of x of the turning point. Then what do you do with that value of x of the turning point? You are going to take it and substitute in that original equation so that you can get the corresponding value of y. So it means where there is x, I am going to replace it with 3. It is equals to 3 again, then I square, minus 6. Then where there is x again, I substitute the 3 plus the 5. So g at 3, it is equals to 3 to the exponent 2. It's going to be a 9, and then 6 times the 3 is going to be an 18. So you'll have 9 minus 18 plus 5, which is going to be negative 4. So it means when x is 3, y it's going to be negative 4. So you can either use this method, or since you already have the x-intercept, you can just add the values of the x-intercept and then divide them by 2. Ne? We have the first value of the x-intercept, which is 5 is to 0. And we have another one, which is 1 is to 0, right? Let me just say or. Let me use a different color so it doesn't confuse you. So we can just create a space here. So you have the x-intercept and you also have that x-intercept, right? So you are going to have this value of x, it's 5. Plus that value of x, which is 1, you divide it by 2, right? Then 5 plus 1, it is going to give you a 6 divided by 2, which is going to be a 3. So it does give you the same value of x as the value of x that you get when you're using negative b all over 2a. So you're still going to get the same marks as if you are doing this one or if you are doing that other method. But negative b over 2a also x. But if you have the x-intercept, you can also find the midpoint of those two x-intercept. And you still get a 3. And that 3 that you get, you take it, you substitute in that in the original equation. Then you find the corresponding value of y. Okay? And that's your 2 marks. So you get a mark for getting the value of x, and you get a mark for getting the value of y, which is just going to be your 2 marks. Okay, and now the question says we need to sketch the function of g. So first things first, we know that it's g of x, it's equals to x squared plus, minus, it's minus 6x plus the 5, right? So as you can see here, the value of a is greater than 0. Your a is positive. So we said if your a is positive, then your graph is going to smile. It's going to be happy, right? So it means this is the shape that we are going to have. You have your y-intercept. We set your y-intercept, it is 0 is to 5. And we have your x-intercept. We set your x-intercept, it was 5 is to 0. And we also have 1 is to 0. Then we also have the turning point. We set our turning point, it's going to be 3 is to, was it negative 4? Yes, it's negative 4. So you have these points that you need to plot. Okay, so we need to sketch our Cartesian plane. Okay, you will be using your ruler and making sure the spaces in between, they are the same. Okay, so I am going to say this side, it is negative, it's negative value, so it's negative 1, it's negative 2, it's negative 3, it's negative 4. And then this side, it's 1, 2, 3, 4. Let's continue up until 5. Okay, and then this side, the values of y, they are negative, right? Okay, so it means you'll have negative 1, negative 2, negative 3, negative 4, negative 5. And this side, you'll have positive 1, positive 2, positive 3, positive 4, and positive 5. Ne? Okay, so first things first, I have my y-intercept, which is 0 is to 5. So when x is 0, y is 5. Remember, along the y-axis, x, it is equals to be 0, right? So it means that point, it's going to be on top of the line of the y-axis because it's a y-intercept. Ne? And then secondly, we go to our 5 is to 0, which is the x-intercept. So you go to your x-axis, you look for positive 5 because your value of x is 5. So on your x-axis, you'll notice that your 5 is going to be on top of the line again. And then you have 1 is to 0, that's another x-intercept. So your point is going to be on top of the line again, it's going to be there. Then your value of x, it is 3. This is the turning point. The value of x is 3. So here's our 3, and the value of y is negative 4. So it means when x is 3, this is x is 3, and y is going to be negative 4. So it means our point is going to be here. Ne? Then you just construct a line, make it a smooth curve. Don't use a ruler. Ne? You need to make it a smooth curve. No ruler, please. Then your shape just came out on its own. You have your x-intercept, which is 1 is to 0. You have your x-intercept, which is 5 is to 0. And you have the y-intercept, which is 0 is to 5. And you have the turning point, which is 3 is to negative 4. And you have your graph of g of x. Ne? So if they ask you to find the axis of symmetry, your axis of symmetry of this graph, where your graph is going to be at positive 3, right? The line or the equation of the line of axis of symmetry, it's going to be x is equals to 3, right? This is the line of the axis of symmetry, where it cuts the graph into 2 equal halves. Ne? And then when they say you need to find your domains, it's all the values of x that are covered by the graph, right? So you can see that your graph, this side, it covers the positive values of x, it covers the positive values of x, and if it continue going up, it's going to cover the negative values of x. Even this side is going to cover all the positive values of x. So it means you'll say x is an element of real numbers. Or you can say x is an element of negative infinity is to positive infinity, because your graph, it's going to cover all the positive values and all the negative values of x. And then going to the range, remember we are talking about the values of y whereby your graph is going to be defined. Ne? Okay, so your range, it is going to be, we are looking at the values of y. So you can see that from here, from -4, this is where your graph is going to start, right? It starts from -4 and it goes up. So you will have -4, -3, -2, -1, 0, 1, up until positive infinity. But at -5, do you have a graph? No, you don't have a graph, because your graph starts exactly at -4. So it means from -4, it goes up, it increases. So you can say y is greater than or equals to, since we are talking about the values of y, you are going to take that value of y, which is -4. Your graph from -4, it goes all the way up. So you can either write it like this, or you can say y is an element of, your graph starts at -4, right? Exactly at -4. So even the -4, it's included. So it means you'll put a square bracket. You say it is -4. Remember the square brackets, it means the -4 is included. Is to positive infinity, because it continues up until infinity. We don't know where it's going to end. So you say up until positive infinity and you put that bracket. You're still going to get the full marks as when you say y is greater than or equals to -4. Okay? Okay, this is the equation of the domains and the range. We have already answered. We said the domains, it's going to be x is an element of real numbers. And then we said the range is going to be y is greater than or equals to -4. Or you say y is an element of -4 is to positive infinity. Or you say x is an element of negative infinity is to positive infinity. It doesn't matter which method you use, but you are still going to get the full marks. Quickly, let's look at the graph of y. It's equals to a into x plus p squared plus q. What if your function or your equation, it's now given in terms of y, it's equals to a into x plus p squared plus the q? And then, so we are still going to do the same thing. You're going to look at the shape. You're still going to look at your value of a. So if your a is greater than 0, then your graph is going to smile. And if your a, it is less than 0, your graph is going to frown, or it's going to be concaving down. Ne? And then your turning point, the coordinates of the turning point, as I had already explained, they are being given by p is to q. So it means this value of p is the value of x of the turning point. So it's the x value of the TP. Then the q, it's going to be the y value of the turning point. Ne? This is still that graph of y, it's equals to a into x squared plus p. The only thing that has changed here, we have introduced this p, which is going to be the horizontal shift. So now your graph is going to be shifted horizontally. Ne? And if you are taking out this value of p, you need to remember that it changes the sign. So if it's x plus p, it's equals to 0, your x will be equals to negative p. The sign needs to change. And if it's negative, it changes to be positive. Ne? Okay, but we'll see when we are doing it. And then 3, you need to know how to determine the x-intercept. We have done that already. And how do you determine your x-intercept? You need to let y to be equals to 0. Then number 4, you need to know how to determine the y-intercept. And the only way to determine the y-intercept, you need to let x to be equals to 0. Okay, let's look at the graph of negative into x minus 3, close bracket squared plus the 4. So the first question, it says we need to determine the turning point, right? Turning point already. I have told you that your equation, which is given as y, it's equals to a into x plus p squared plus q. The p and the q, it's going to be your turning point, right? So in this case, your P, it's the same as this -3, right? But you don't just say your P is equals to -3. The sign needs to change. So if you have x minus 3, if you are solving for x here, x minus 3 is equals to 0, you'll take the minus 3 to the other side, and your x is equals to +3, right? So it means the P of the graph, it's going to be your turning point. It's turning point. Its P is to Q, ne? So the value of P here, instead of -3, you'll write it as +3, is 2. The value of Y, it's going to be +4. Then you have your turning point, ne? Please don't write it as -3, because if you write it as -3, it is going to be incorrect. Okay, and then let's look at the second question. It says we need to determine the x-intercept of that graph, right? So what are you going to do? You are going to say, oh, okay, the x-intercept, you need to let y to be equals to 0. Then it means where I see y, I'll substitute 0, it's equals to negative into x minus 3, I square plus the 4. So since I want to be left with x only, it means I need to transpose the +4. If I transpose the +4, I will have -4, it's equals to negative into x minus 3 and I square. Then I need to get rid of that negative. For me to get rid of the negative, remember this is -1, I'll divide by -1 and also divide by -1. Negative and negative, negative being divided by negative, it gives you a positive, right? And also here, -4 divided by -1, it's going to give you a +4. It's equals to x minus 3 and squared, right? So since I want to be left with x, I need to get rid of that exponent, which is 2. So I'll put a square root of 4 and also put a square root of 4. Sorry, and also put the square root of the whole thing. Then the square root of 4, it's going to give me plus or minus the 2. Ne? Then I will have it is equals to, the square root cancels that squared, then I'll be left with x minus the 3. Okay, so I will have +2, it's equals to x minus 3. I take the -3 to this side, so I'll have 2 plus the 3, it's equals to x. And then my x, it is equals to 5. So the first x-intercept is going to be 5 is to 0. Or the others, x-intercept, you equate to -2 now. So it's going to be -2, it's equals to x minus 3. You take the -3 to this side, it becomes +3. So you'll have -2 plus the 3, it's equals to x. Then -2 plus 3 is going to be 1, it's equals to x. Then when x is 1, y, it's going to be the 0. Ne? And then you get your full 2 marks. So you'll get a mark for letting this to be 0. And you'll also get a mark for, okay, I'll give you a mark at 1 is to 0 and also get a mark at 5 is to 0. And that's just your 2 marks. Okay? And then determine the y-intercept. Let me let you do this one for a minute. For 1 minute, please find the y-intercept. So how do you determine the y-intercept? Again, you're just going to say let x to be equals to 0, right? So where you see x in that equation, you're going to substitute 0. So it's f into 0, it's equals to negative into 0 minus 3, you square plus the 4. So f at 0, it's equals to negative. The -3 squared is going to be +9. Then plus the 4. Then f at 0, it's equals to -5. So it means when x is 0, y, it's going to be -5. Okay? And then let's sketch our graph. So I have the y-intercept. We set the y-intercept, it's 0 is to -5. And then the x-intercept, we said 1 is to 0, and we also said, I think it was 5 is to 0. Was it positive? Let's just double check. So you have 1 is to 0 and you have 5 is to 0. Then you have a turning point, 3 is to 4. Then the turning point is 3 is to positive 4. Then don't forget the shape. Your A there, it is less than 0 because it's f of x, it's equals to negative into x minus 3. Ne? So it means your A is negative. So it means your graph is going to frown, or it's going to concave down, and it's going to have that maximum value there. Ne? Okay. This is my Cartesian plane. That's your Cartesian plane. You have -1, -2, -3, -4. I have 1. Let me start here. 1, it's 2. It's 3, it's 4, and it's 5. Here I have 1, I have 2, I have 3, I have 4, I have 5, I have 6. And then you will have -1, -2, -3, -4, and that -5. Okay, so the y-intercept exactly on top of the y-axis. Let me use a different color. Exactly on top of the y-axis, I will have that y-intercept. 0 is to -5. Ne? And then the turning point, when x is 3, y it's going to be positive 4. So it means where those two meet, I'll have a point. Ne? That's my turning point. And then I also have the x-intercept. When x is 1, it's going to be here. And when x is 5, it's going to be somewhere there on top of that line of the the x-axis. From there, I just construct a smooth curve. Please don't use a ruler. A smooth curve, ne? Going down, and a smooth curve going on top of the y-intercept, and I have my shape. Ne? Make sure you put the arrows to show that the graph is continuous. The graph is continuous. Ne? And that's your 3 marks. So you do get a mark for the shape of the graph. You do get a mark for the turning point, for your turning point, and you do get a mark for the intercept with the graph. So for sketching your intercept correctly, you do get a mark, and that's your full 3 marks. Okay, then they say now we need to determine the domains and the range of f. So we said the domains is going to be x is an element of real numbers, or x is an element of -infinity is to +infinity. Ne? And then these are my domains. My range, it's going to be y. Since our a is less than 0, it's going to be y is less than or equals to the value of q. In that case, what is the value of q here? Because from here, if you are looking at your values of y from -4, from +4, it's going to go down to -infinity. So it means it's going to be your y is less than or equals to +4, because we are starting exactly at +4. Ne? Or you can say y is an element of, it starts from -infinity is to +4, but at +4, the +4 is included, and you put that square bracket. So either you write this one or you write this one, but you still get your full 2 marks. Okay, and then how do you determine the equation of a parabola? Okay, so you can be given 3 cases. The first case, you can be given a turning point. You can be given a turning point and one other point. So which equation has a turning point? It's the equation of y is equals to a into x plus p squared plus q, right? So it means if you are given a turning point and one other point, you are going to use that general equation to find the equation of a parabola. Ne? And then what if you are given the x-intercept and one other point? So if you are given the x-intercept, you are going to use the equation of y it's equals to a into x minus x1 times x minus x2, ne? Whereby your x and your y, these are the x-intercept that you'll be given in that case, ne? And then this x and this y, it's going to be this other point that is given. You just substitute everything, you solve for a, then you have your equation. Okay, moving to number 3, what if you are given 2 points and the y-intercept? So if you are given the y-intercept, you are going to use the equation with the y-intercept, which is y, it's equals to ax squared plus bx plus the c, right? Whereby your c is going to be your y-intercept. Then these 2 other points, you'll substitute the first one, then you'll have the unknown as a and b. Then if you substitute the other one, again, you'll have the unknown as a and b. Then you are going to solve for a and b simultaneously. We have done that in term 1. Okay, let's look at that example. It says, determine the equation of f of x shown below if the point -4 is to 4 is its turning point and -2 is to 2 is a point on the graph. You must write your answer in the form of f of x, it is equals to ax squared plus bx plus the c. So we are given the turning point, right? You are given the turning point and you are given any other point. You know that your turning point is given as p is to q, right? And then any other point, it's given as x is to that y. Ne? So it means you are going to say, okay, since I am given p and q, I need to use the equation with p and q, right? So it's going to be y, it's equals to a into x plus p, your square, plus the q. Ne? So you will have your y, it's equals to a into x. The p, remember we said your p, it changes the sign, right? So you have -4. So when I'm substituting here, I'll substitute +4 because I have -4. Then it's squared plus the q, it's given as +4. I still have 3 unknowns. I have the y, I have the a, and I have the x. But I still have more information that I haven't used, which is -2 is to 2, right? Okay, so you say the value of y here it's given as 2. So where I see y, I am going to substitute 2. You say it is equals to a. Where you see x, you are going to substitute -2 plus the 4, you square plus the 4, right? And now you only have one unknown, which is a. So we need to solve for a. Okay, so the 2, I take the 4 to this side, it becomes -4. It's equals to a into -2 plus the 4, I'll get +2 and you square. So 2 minus 4, it's going to be -2, it's equals to 2 squared. It's going to be a 4 times a, right? Okay, from there, you will have -2, it's equals to 4a. You divide by 4, you divide by 4. Your a, it's equals to -1 all over 2. So now I have the value of a. So you can take this value of a and substitute where? And substitute here. Ne? So it means you will have y, it's equals to -1 over 2 into x plus 4, I square plus the 4. They said we must write our answer in terms of ax squared plus bx plus c. So it means we need to expand those brackets, or we need to simplify here. So it means I will have y, it's equals to -1 over 2. I open 2 sets of brackets here. It's x plus 4, and I also have x plus the 4 plus the 4. So it's y, it's equals to -1 over 2. Here you multiply x and x, you get x squared. X and 4, you get 4x. 4 times x, you get 4x. And if you add 4x and 4x, you get 8x, right? And then the last one, you say 4 times the 4, you will get 16. So I'll say x times the x, I'll get x squared. X times 4, I get plus 4x. 4 times x, you get plus 4x. And 4 times 4, you'll get the 16. You still have plus 4. So y, it's equals to -1 over 2 into I have x squared plus 8x plus 16 plus the 4. You still have the negative 1 over 2, which is multiplying everything that is inside the bracket, right? So you'll have negative 1 over 2 times x squared. Then you'll have y, it's equals to negative 1 over 2x squared. Then negative 1 over 2 also multiplies the 8x, which is going to be now minus 4x. Then if I multiply negative 1 over 2 with 16, I'll get negative 8 plus the 4. You still have that 4. Okay, so you'll have y, it's equals to negative 1 over 2x squared minus 4x minus 8 plus the 4. You'll get minus the 4. And that's your graph. Then you get your full marks. So whenever you're given the turning point and a point, you need to use the general equation y, it's equals to a into x plus p squared plus the q. Okay, let's look at example 4, when you are given the x-intercept and one other point. So when you are given the x-intercept, you can see this is an x-intercept and this is an x-intercept. Then you are given this one other point. That's not a turning point, it's just any other point on the graph that is given by 2 is to negative 24. So I have the x-intercept and I also have the x-intercept. So you are going to use your equation of y, it's equals to a into x minus x1 and x minus x2, right? Remember I said x1 and x2, those are your x-intercept. So it means here when I'm substituting, I'll have y, it's equals to a into x. Where I get x1, I am going to substitute negative 2. So I have the negative of the equation. I have this negative of the equation. Then I will have negative 2. So I substituted this one. It comes with a negative. Then in the other brackets, I still have x minus the other x-intercept. It's going to be given as positive 5. So I just substitute my 5. Then I close the bracket. Okay, so that is going to be y, it's equals to a into negative times negative is going to give you a positive. So it means you'll have x plus the 2, then you have x minus the 5. You still have 3 unknowns, which is the x, the a, and the y. But you still have the information in the graph that you haven't used, right? So what are you going to do? You are going to take that coordinate of c and you substitute where you see x and substitute where you see y. So the value of x here is given as 2 and the value of y is given as negative 24. So it means where I am seeing y, I am going to substitute the value of y, which is negative 24. Then I say it is equals to a into, where I see x, I am going to substitute my value of x, which in this case it is given by 2, right? I still have the plus 2, close the brackets, you open a bracket, you are seeing another x there. So again, because there is an x, you are going to substitute the 2, then it's going to be minus 5. That's a 2. My 2 is not appearing nicely. It's a 2, like that, right? Then we can just simplify from there. So I have negative 24, it's equals to, I still have the a into 2 plus 2, it's going to give you a 4. Then a 2 minus 5, it's going to give you a minus 2 minus 5 is going to give you a minus 3. Then you close the bracket. Okay, so it's negative 24, it's equals to 4 times negative 3, it's going to give you negative 12a. Then since I want to solve for a, I'll divide by negative 12 and I also divide by negative 12. So negative 12 divided by negative 12, I'll get an A. It is equals to 24, negative 24 divided by negative 12. It is going to give me positive 2, right? So I have the value of A now, so it means I will have Y, it's equals to, where there's A, I substitute 2, then it is X plus 2, and it is X minus the 5. Let's just double check. Yes, it's X minus 5. So I can just expand here. So I will have Y, it's equals to 2. First things first, we deal with this bracket and that bracket. So you'll say your first term multiplies the first term, you get X squared. The first term multiplies the last term, which is going to be minus 5X. The first term, the second term, and the first term in the other bracket, it's going to be plus 2X. And 2 times negative 5, it's going to be negative 10. So Y is equals to 2 into X squared. Minus 5 plus 2 is going to be minus 3X minus 10. You close the bracket like that. Then Y is equals to 2 times X squared. It is 2X squared. 2 times negative 3X is going to be negative 6X. And 2 times negative 10 is going to be negative. It's going to be negative 20. So that's going to be your equation. Your A is 2, your B is negative 6, and your Y, it is given as, sorry, your C, it is given as negative 20. Okay, take time and digest all of this. I'm moving to the last case or the last scenario. When you are given 2 points and the y-intercept now. So the question says a parabola's y-intercept is at point 0 is to negative 2. So you are given the y-intercept, right? And then if points B, which is 2 is to 8, and point C, which is negative 8 is to negative, negative 6 is to negative 8, are points which lie on the graph, determine the equation of the parabola. So they are saying you have the y-intercept, then you have these 2 other points, right? So let's start with the y-intercept. Let's start with our y-intercept. Our y-intercept is given as A is 0 is to negative 2. So we substitute it, y is equals to ax squared plus bx plus c. So our y-intercept is just going to, the negative 2 is just your c, but let's just substitute nicely. So when x is 0, y is negative 2. So y is negative 2 plus a into your x is 0 squared plus b is 0 plus c. So negative 2, it's equals to c, right? So let's take it back. You'll have y, it's equals to ax squared plus bx minus the 2. Ne? Then in this equation, I have how many unknowns? I have y, I have a, I have x, and I have b. So I have how many unknowns there? I have 3 unknowns. Ne? But if we can substitute this point, the only unknown I'm going to have is going to be a and b. And if you substitute this one, the only unknowns that you are going to have is going to be a and b. And you can solve simultaneously. Ne? Okay? So you have y, it is equals to ax squared plus bx minus 2, right? So we are going to substitute the first point, which is 2 is to 8. So I have my coordinate of b, which is 2 is to 8. So when y is 8, x is 2. So where I see x, I'm going to substitute the 2. So I will have 8. And let's take the negative 2 to the other side. It's going to be positive 2. It's equals to 2 squared. It's going to be 4a. And then 2 times b, it's going to be 2b. Right? So it's going to be 10. It's equals to 4a plus 2b. Then you say this is equation 1. Ne? Okay. Then let's substitute the other point, y is equals to ax squared plus bx minus 2. The other point, the point of C, it's negative 6 is to negative 8. It's negative 6 is to negative 8. So where I see y, I am going to substitute negative 8. And where I see x, I'm going to substitute negative 6. Right? Okay, so here I can see there's y. I'll substitute negative 8. It's equals to a into where I see x, I substitute negative 6. I square plus b. Where I see x, I substitute negative 6. It's minus 2. I take the minus 2 to this side. Then I'll have minus 8 plus 2. It's equals to 36a minus 6b. So it's going to be negative 6. It's equals to 36a minus 6b. Is it 6b? Let me just double check there. Negative 6 squared. Okay, that's negative 6. That's okay. Then I have equation 2. So between the two equations, you can choose which one you want to make equation 3. Then you take that equation 3 and substitute to the other one. So I am going to use equation 1 to make equation 3. So you say make equation 1 to be equation 3. So I will have 10. I'll take the 4a to the other side. It becomes minus 4a. It's equals to 2b. Then I divide by 2, and divide by 2. So I will have 5 minus 2a. It's equals to b. And this is going to be our equation 3. Then you take your equation 3, you substitute in equation 2. Because why are we not substituting in equation 1? Because we have used equation 1 to make equation 3, right? So it means your equation 3, you substituted in equation 2 because you didn't use equation 2 to make equation 3. Okay, so you say substitute equation 3 into which equation? Equation 2, right? So I'm going to take this and substitute here. So wherever I am seeing b in this equation, I am going to substitute 5 minus 2a. So I will have minus 6, it's equals to 36a minus 6. Where I see b, I substitute 5 minus 2a, right? Then we can multiply everything. If I multiply everything, I'll have negative 6. It's equals to 36a. Negative 6 times the 5. I am going to get negative 30. And negative 6 times negative 2a, I am going to get positive 12a. So I can group my like terms. I can take the negative 30, this negative 30 to the other side. So I'll have negative 6. If I take the negative 30 to the other side, I'll have positive 30. It's equals to. Then I will have 36a plus the 12a, because I'm grouping my like terms. What is 36 plus the 12? You'll get 48a. Then from there, we can divide by 48 both sides. So if I divide this side by 48 and I also divide this side by 48, I'll get that a, it's equals to negative 6 plus the 30, you will get 24. And 24 divided by 48, you will get 1 all over 2. So your a is 1 all over 2. Okay, we don't have space anymore. I'll have to erase. Okay. So now I have my value of a. We said our a is given as 1 over 2. So this is a continuation. I have a, it's equals to 1 all over 2. Then I can take my a and substitute either in equation 1, in equation 2, or even in equation 3. So I am going to substitute in equation 3. So you say substitute equation, or you substitute a, it's equals to 1 over 2. Into which equation? Into equation 3. Let's go check for equation 3. Okay, this is our equation 3. So I'm going to substitute it there. 5 minus 2a, it's equals to b. So your b, it's equals to 5 minus 2a. So b, it's equals to 5, negative 2. Where you see a, you substitute 1 over 2. Then you will have 5 minus 1, which is 4. Then it means your b, it's given as 4. Therefore, your equation will be y, it's equals to a, it's 1 over 2, x squared. Your b, it's plus 4, x, and then your c, we said it is minus 2. Then this is our equation. So you substitute your y-intercept, then you substitute 1 point, then you'll have a and b as an unknown. And again, you substitute the other point, which is negative 6 is to negative 8. Then again, your unknown is going to be the a and the b. Then you have to solve simultaneously for a and b. Then your equation will be given as y. It is equals to 1 over 2x squared plus 4x minus the 2. Okay, let's continue. Let's look at the effect of p on a parabolic function. So remember, in grade 10, you were only used to the function of ax squared plus the q, right? P is a new parameter to you. Okay, so first things first, let's sketch the graph of f of x is equals to x squared. Remember, the graph of f of x is equals to x squared. You can do, let's do a table. So the graph of f of x, let's substitute into our x squared. So our values of x, let's use negative 2, negative 1, 0, 1, and the 2. So if I substitute all of these values, if I substitute negative 2 there, I will get, if I substitute negative 2 where there's x, I'll get positive 4. If I substitute negative 1 where there is x, I am going to get, if I substitute negative 1, I'll get 1. If I substitute 0, I'll get 0. If I substitute 1, I'll get 1. If I substitute 2, I'll get a 4. We don't even have to do that though, yes. But it's okay. Let's just do it. Okay, so this graph, you'll have 1, you have 2, you have 3. You have negative 1, negative 2, negative 3. You have negative 1, negative 2. You have negative 3. You have 1, you have 2, you have 3. Right? Okay, so the graph, when x is negative 2, y, it's going to be positive 4. So it's going to be somewhere up there. Then when x is negative 1, y, it's going to be positive 1. It's going to be somewhere here. And when x is 0, y, it's going to be 0. When x is 1, y is 1. Then when x is 2, y, it's going to be 4. It's going to be somewhere up there, right? Okay. Then if I sketch this graph, it's going to have a shape that looks like that. This is the graph of f of x, it's equals to x squared. But what if now your p, your value of p, has been introduced where there is x. Now we have x minus 2. So here they introduced a minus 2. Your graph has been shifted 2 units to the right, right? Okay, let's see what's going to happen. Let's use a different color. Now we are looking at the graph of x minus 2 squared. We are still looking at the same values of, we are still going to look at negative 2. But if now there is minus 2, it is going to shift. Okay, so I'm still looking at negative 2, negative 1, 0, 1, and the 2. So it means the value of y now is going to be, I say it's negative 2 and I square, negative 2 minus the 2 and I square. The new value of y is going to be 16. And then if I substitute negative 1, it's going to be 9. No, this graph is going to be too long. It's going to be too huge, ne? Let me just show you the shift, because from here, I'll have to have a huge space so that I can be able to draw that graph, ne? Okay, so here it's now x, it equals x minus 2. So if I take out this value of x, it's going to be x minus 2, it's equals to 0, right? Which is x, it equals to positive 2. So it means instead of your graph having a value of x of the turning point at that 0, it's now going to turn where? It's going to turn here at positive 2, right? You're still going to have the same shape, but now your graph is going to turn like this. The turning point is now at positive 2, ne? Meaning that your graph has shifted from 0 to 2. It has shifted 2 units to the right. And if it's x plus the 2, x plus the 2, if you are solving for x there, you'll get x is equals to negative 2. Then from there, your graph is now going to turn here instead of turning at 0, right? So your graph is now going to turn at negative 2, meaning that your graph is going to be like this. From here, your graph is now here. So it means your graph has shifted 2 units to the left. It has shifted 2 units to the left. So it means when you have x plus the p, your graph is going to shift 2 units to the left. And if it's minus the 2, then it means your graph has shifted 2 units to the right. I hope that is making sense. Okay, so your P, it shifts your graph horizontally. It can either move it to the right or move it to the left. And then the effect of Q, this is just a revision. You have done it in grade 10. If you have this graph of, let's look at this one. Let's say you have that Cartesian plane. You have still the graph of f of x. It's equals to x squared. This is the graph of f of x, the original graph. It's equals to x squared. Ne? Then you have now g of x, the new graph, which is given by g of x. So your g of x, they say it's equals to f of x plus the 3. So from whatever that you have on your f of x, you now have x squared plus the 3, meaning that your graph has been shifted 3 units upwards, because remember your value of q, it shifts your graph vertically, ne? So it can either go up or go down. So it means the new graph is now going to be at, since it's positive 3, instead of turning here, it's now going to turn at 3. So let's say it's 1, it's 2, it's 3. Let's say you have 3 here. The new graph is going to now turn at positive 3. Your graph has shifted 3 units upwards. So here, your graph has shifted 3 units upwards. Ne? And it means if I subtract 3 from x squared, then it means my graph is going to turn, instead of turning here at the origin, it's now going to turn at 3. So meaning that it's going to shift 3 units downwards. So now I'll have a new graph that goes like this. So this graph has shifted 3 units downwards. This is the new graph of g of h of x. It's equals to f of x minus 3. It has shifted 3 units downwards. Okay, I hope you still remember this. It's very important that you remember the effect of q and the effect of p, so that you can be able to answer the questions that has to do with translation and the reflection. Ne? So in summary, what you should have learned today in this lesson, you should have learned that if a is greater than 0, your graph is going to concave up like this. As a result, you are going to have a minimum value. And if a is less than 0, your graph is going to concave down, making you having that maximum value, right? And for you to sketch your graph, you need to know the shape, you need to find the x-intercept, you need to find the y-intercept. Ne? And then we have the P, which represents the horizontal shift. Your graph can either go to the right or go to the left. So when you are subtracting a value of x from, if you are subtracting P from x, your graph is going to shift P unit to the right. And then if you are adding that P unit from that value of x, then your graph will shift P unit to the left. And looking at Q, Q shifts your graph vertically. It can either go upwards or go downwards. So if you have plus P, or sorry, if you have plus Q, your Q is being added, your graph is going to shift Q units upwards. And if you have Q, if Q is being subtracted from your function, then it means your graph is going to shift Q units downwards. Okay, thank you for tuning in today's lesson. Your worksheets will be shared with your teachers, then you can be able to practice and see if you grabbed anything in today's lesson. Thank you.